Good day, grade 11s. Today we are going to look at analytical geometry. Please remember this is a new topic. Please start it on a new page in book 1. Okay. Okay, we'll start with a recap of what you did in grade 10. So that's what we're going to be doing today. If you are given any two coordinates or points, so we call them coordinates or points. If the first one is A, remember there's no equal sign between the letter and the actual bracket. So A, which is X, remember coordinate is XY. So XA, YA. So this is just to indicate that these are coordinates of A, and then the coordinates of B, then we indicate like that. Sometimes other people use X1, Y1, and X2, Y2. Okay, so if you are given any two coordinates, there are three things that you calculated in grade 10. The first one was the distance between point A and point B, or the length of the line AB. Okay, so that one you calculated using this formula, which comes from Pythagoras. So AB squared is going to be the difference between the x values squared plus the difference between the y values squared. And then because we are looking for AB, then it is going to be the square root. You take the square root on both sides. So AB will be the square root of what was calculated at the top. I just write it like this. It is also acceptable that you just write the step like that instead of starting here. And then you can just, as long as you've written the formula, you've written your substitution, you can then just put this exactly as it is in your calculator without having to figure out what this is, because sometimes you guys make mistakes over here. All right, and then don't forget, because this is length, we have to write the units. So in most cases we just use units instead of unless you are told that it's centimeters or what. So in this case we use units because we don't know what the units are. Okay, and then the second thing that you calculated was the gradient or the slope of the line AB. Remember the slope or the gradient is how steep the line is. Okay, so the gradient uses again the two coordinates that you have. Okay, so this one, the formula for the, okay, we use the small letter m to represent the gradient, right? And then when you calculate, remember it is the rise over run, so it's always the y values first before the x values. Please don't forget that, because if you mess this up, then it messes everything else that follows that needs the gradient. Okay, so the gradient of a line is y b minus ya over xb minus xa. Now notice how this is, it's just the b coordinate and then this is the a coordinate. Don't swap them around. If you started with the b coordinate, then it must be b minus a in both y and x. It mustn't be a case where this is b and then at the bottom then it is then a minus b. Make sure that the order is maintained. It can be also written as it could also be ya minus yb. Doesn't matter which coordinate you start with, but what matters is that you maintain the order. Okay, right? And then we also did, okay, so the gradient is calculated like that, which we can then use to find the equation of the line AB. Okay, the equation of the line AB will be calculated using this equation. Y is equals to ya or b, depending on which coordinate you choose, equals to m, the gradient, times x minus xa. Remember, this is just y and this is x. And then xa, I mean ya and xa are the values of the coordinate a, or if you choose to use coordinate b, then it will be the coordinates of coordinate b. the values of coordinate B. Then this will then simplify. You'll see when we do examples, this simplifies to the equation y is equals to mx plus c. So you start there and then you simplify it to that. Y is equals to mx plus c, where m is still the gradient, the x, this one is this one, the y is that one, and then c is the y-intercept, which comes from simplifying this one and that one. Okay, so this is an equation. Usually, this equation is for the slanting line, the straight slanting line, like that, the one that has a slope. Okay, so then parallel lines will have the time gradient. This is just a recap of the things that you did. That's why I've written all of them here. The parallel lines will have the same gradient. So that means if I have line AB, which is parallel to line CD, then their gradients are going to be the same. So the gradient of AB is the same as the gradient of CD. Then if you know the gradient of this one, you can use the gradient of AB to maybe find the equation of the line CD. Okay, if you are told that the lines are perpendicular means at the point of contact they make 90 degrees. So you've got line AB and line CD. Now the relationship between these two is that the gradient of AB is the negative reciprocal of CD. It is the negative reciprocal of CD, which you can write like that. Some books also write it like this. They say the gradient of AB times the gradient of CD will be equals to -1. It still means the same thing as this. Okay, if you multiply the gradient of AB and the gradient of CD, if you get -1, then it means the two lines are perpendicular to each other. We use this most of the time when we want to show that the angle at the point of intersection is 90 degrees. Okay, please don't forget that. Okay, right, then the equation of a horizontal line, I just thought I would mention this. Remember, a horizontal line is that one that is going to be parallel to the x-axis. And now if you remember, the x-axis has an equation which is y equals to 0. And the reason for that is that all the coordinates that lie on this x-axis, this one, if I had a coordinate here, it would be 1, 0. This one would be 2, 0. This one will be 3, 0. So in all these coordinates that I have here, the y value is 0. So the equation will be y equals to 0. And then if I have a line which is parallel to the x-axis, and then it crosses the y-axis at C, then the equation will be y equals to C. Okay, and then for a vertical line, the vertical line is parallel to the y-axis, so it is vertical like that. And then the equation of the y-axis is x equals to 0. Now x equals to 0, and the reason, again, if I have a number here 1, this coordinate, remember this is the origin, which is 0, 0. Then this one, if I had a 1 there, this coordinate here would be, that coordinate would be 0, 1. Then the other one would be 0, 2. This one will be 0, 3. So in all these coordinates, the x value there is 0. So that is why we say the equation of the line is x equals to 0. So the equation of any other line which is parallel to the y-axis is then going to be x equals to d. D being the point where it cuts the x-axis. So please don't forget, a tendency is people will then write this one as y because it is parallel to the y-axis until we look at the point where it cuts the x-axis. So if it cuts the x-axis, then the equation will say x equal to. If it cuts the y-axis, then it will say y equals to. Okay, and then you see this one cuts the x and the y axis, so that is why it will have both the y and the x in its equation. Okay, and then I just wrote this for Just to remind you, remember the line that goes up like that, we say it's an increasing line. The gradient there is positive. Then this one, the gradient is negative and it is a decreasing line. Okay, it's a decreasing line, right? And then the third thing that you calculated was the midpoint of the line AB. Okay, the midpoint, we're just looking for the middle. So you add the two x coordinates, you divide by 2. You add the 2 y coordinates and you divide by 2. As simple as that. Okay, so I've given an example. This is your A coordinate, this is your B coordinate. You have to calculate the midpoint, then the gradient, then the length of the line. Okay, so I started with the midpoint, so it is 1 plus 7. So it's the x values first and then the y values first. So x plus 7 is 8 divided by 2 is 4. And then negative 1 plus negative 3 is negative 4 divided by 2, I get negative 2. Please notice there's no equal sign between the m and the bracket. Please write like that. If you put the bracket, then your marks will be deducted. Right, calculate the gradient. Now we're looking for the gradient. Now remember, gradient, it's y over x, not x over y. Okay, y over x. So we start here by the y value. So you write the formula, then you substitute negative 1 minus negative 3. So negative 1 minus negative 3, this one makes a plus. So it's, you can actually write it like that, negative 1 plus 3, which is 2. And then at the bottom, it's then 1 minus 7. 1 minus 7 is negative 6, which then simplifies to negative 1 over 3. Please leave it as a fraction in its simplest form. Don't write it as a decimal. Write it as a fraction in its simplest form. Okay, the length of the line, I'm still using the same coordinates. The length of a line, now remember, the length of the line is the difference between the x values and the difference between the y values. So 1 minus 7 is negative 6 squared, and then negative 1 minus negative 3, which will give you. And then if you are calculating the length, if you have written it like this, you can then just, as long as you have shown your substitution, you can then just straight, put this in your calculator and then go to your answer. Don't show this these two steps, because sometimes you make mistakes and then you don't use brackets and then it messes up your answer. So just use this, substitute, and then go straight to your answer like that. Okay, so you leave your answer like this unless the question states otherwise. Then you can simplify to 2 decimal places. It is always safe to leave your answers in insert form. Okay, so that's basically what you did in grade 10. So please do exercise, the revision exercise on page 64. Number 1B, number 2, number 3 AC, number 4 ACE. All right, I hope everything is in order. Thank you.